Good. So we are able to think about what exactly have been done. So I'll do one thing. I'll just take you through this stress distribution I am saying. So this case, the load position we have not changed. But what we have done is the force, whatever you had, the load, whatever you had, the area through which it was acting has been widened. So what we are expecting from the students, if they have experienced force by area as the pressure and the pain which comes from this is an experiment which you can ask students to do it in the class. Let them just press each on uh, the pencil on either side, and they can experience what is meant by pressure and what is meant by force by area. So if they are able to give you this answer, that means they have experienced the concept of F by A. Otherwise, they have remembered the concept. Okay, let us look at the second case. Here, I want you to go beyond our normal activity of static analysis. I'm also taking you to the dynamic analysis. The first thing is, I'm moving the load from away from CG to closer to the CG. As the load is moved down to CG, the distance between CG and the load, if there is a displacement, it is small. So arm length for
You're not audible.
is reduced. Arm length for, am I audible, sir? Any issue?
You're not audible. It's breaking. Voice is breaking.
Maybe it's network issue at your end, sir. Professor Gangadharan, sir, your voice is audible.
Yeah, no, Professor, what you can do is, you can mute all the videos coming to you, maybe including mine. There is a provision, you can say you don't need any video, so that audio will be clear. Because many of us will have problem with the network and bandwidth. Okay, so please try looking at it that. You need only the presentation and my audio to come. The rest of the things could be avoided now. As and when you need a chat, you can just open the chat. So here, in this case, the load is moved closer to the CG. Hence, if the load is displaced a bit, the moment which can create due to that displacement is reduced. So assume that something is on the head, and head moves by, from the CG, it moves by, say, small distance. And that much of moment has to be taken care by the hip. That is reduced in this case. And it can be analyzed as a 2 degree of freedom system and can do all lot of analysis using that. And this is the person who found it out, found this method, and he just, it was an assignment for him, in fact. So now, after explaining this, you are going to ask them, okay, this was the case of a load carrying like this. Now, I need water to be carried, but I don't want to have separate bottles or vessels. Whatever you carry, the same vessel I should be able to use. And if you remember the last picture, which I have not explained in the previous slide, and somebody has already put that it is not audible, very clear. Okay, that is, sir, that audible issue is with your network. Please try to come to a better network area. That's the only possibility. Yeah. Now, I want you to look at the third picture which you saw in the previous diagram. This picture, 3, or I'll put it like this. The third picture here. And think about carrying water. Okay. So that is a question which you are going to ask the students. If they are able to come out with an solution, and if you are able to analyze, and if that comes close to what I'm showing or something similar, then they have experienced it. Otherwise, they have just remembered it. Let us see what it is. So you look at the vessel here. This is a vessel. And two sides, there is a supporting element which is added with a stand. And you go fetch the water, put the supporting element on the side, roll it. And obviously there will be wear and tear, but the material is chosen in such a way that only the surface which is stretching on the ground is less, and it is strong, and it is able to do it. So this is Wells on Wheel. It's an NGO from UK, and they distributed a lot of such things in India. And you can see the person who is carrying it. It's so light. And this was the story. I mean, this is how they have developed. Now, you are extending it further because we have different subjects in mechanical engineering. We want everybody to get involved and see. Now, I'm looking at carrying load like this. You're worried today there is only load which is being carried. All of us are carrying so much of load nowadays because we need to have online classes. So I thought the load carrying is the best example to start with. So let us make engineering analysis on this. I want you to look at this picture and see. You ask the students what kind of analysis they can do, which they have studied in 11th, 12th, and some first year classes in engineering. That's it. Look at this. Your bending moment diagram, shear force diagram, all that can be done. You can, suppose you are not happy with it, you want to put in little more dynamics. You can look at oscillation, swing, and you can look at the natural frequency, how much energy is getting consumed in each swing. Can I use this swing for an advantage? Can I swing it in such a way that both gives me a push such a way that the load coming onto my shoulder is reduced? It's possible. People have done, at least I know there are 3-4 papers which I have seen in this area, just on this. So in a class, we should be able to, by looking at in and around, we should be able to give a suggestion like this or place a question like this and see whether our students have experienced the concept. If not, at least our subject, we should be able to make them experience. That's where we are looking at today's and their activity. This is what now something which we are dreaming about. We wish we could go to the class and talk like this and see the real faces rather than the virtual faces. Look at my condition. I have been talking to my screen from April 1st onwards. I have been doing this. And we have finished around 15,000 faculty members so far now throughout this lockdown period, talking about different things on webinar. So I have been smiling at the screen for quite some time. So because we have been asked to do all online. Whatever the minimum facility we have, within that, can we make it much more experiential without really getting trouble too much is the question. Now, take a case of our BTech students coming in the first year. Assume that we are taking BTech in cycling and we will teach everything about cycling, making the cycling, dynamic balancing, static balancing, Newton's law, everything is taught in textbook. And after 4 years, we'll ask Mr. BTech cycle to cycle the cycle. What will happen? You are laughing at me. I know you are laughing at me. And quite often we are doing the same. Assume that our students are BTech in swimming and we make them sit in the swimming pool side and we do this.
Yes, sir. Yeah.
This is my engineering teacher. And at the end, do you think they will be able to swim? And we are expecting that to happen, in fact. So from telling concept to experiencing the concept is what is required now. So we need to make a change from reading engineering to doing engineering, even if it is an online class. So even if you are forced to take an online class, still we should be able to do engineering rather than make our students to read engineering. Let us see how we are going to do it. I'll take 1 or 2 examples of why and how we can put it and the solution part. So I look at automobile is something which is, if you go to any class and ask what is your favorite subject or what is your domain which you look, few will talk about automobile, few will talk about robotics, and obviously now AI and ML, artificial intelligence, machine learning, and all that high sounding words are also quite popular. Now let us look at automobile, and I am going to look at it as connected car. Now I want you to think about what branch it belongs to. Is it nut and bolt mechanical? Or is it a combination of every possible topic or subject, and that too, everything put together, including arts and science and commerce and everything together, is the present day connected car activity? If that is the situation, probably we are restricting ourselves into one domain and we are only giving some input which they are not able to experience is going to be really disastrous. So this is the right time to start making our class more experience. Simple example. Assume that an electrical, electronics, and a computer science and IT student came to you saying that they have a startup idea where they would like to make this, okay? They have not attended your kinematics of machine class and they don't know how the wiper is actually functioning. They know there is a motor rotates and wiper has to wipe. That much is that what they have. But you cannot stop them saying that, look, you are not mechanical, you cannot do this. So assume that you want to give them a support saying that, yes, I'll just tell you briefly what you need to do, and then you can go ahead kind of a statement. Look at this. If someone has given you complete simulated activity of all this and all the building blocks, then probably we could have made it in a small capsule and given it to them and say that you don't need to attend my entire kinematics of machine 1 semester course. What you need, I can tell you quickly, and I can make you experience it even though you are not from my domain.
Yes, sir.
So it is their headache to find how they sense the rain and then adjust the speed based on, start the wiper, adjust the speed based on the rain rate and things of that kind. Or they may go for windshield with a display or photochromatic windshield so that depending upon the light intensity, the opaqueness color can be adjusted. All that is possible. Okay, but first we need to give some experiential input in order to do it. So that was one simple case we have taken. I'll take another case from hard disk. So it is to do with electronics or embedded system, or people can even argue it is for computer science. Now the problem I am facing here is the disk is rotating at 7,000 plus RPM, and the arm which has to move from sector to sector to read as well as to write the information have to move so quickly so that your time to fetch the data is reduced. So demand for time to reduce the time to fetch the data is quite high. Hence, we are forced to make it to move quite fast. And it is not moving just like that because it will stop at every sector, read, again move. So we are disturbing the system as often as possible. Okay. So this, now what is happening is when the arm is moving in and out, it is also moving vertically up and down because of the disturbance, and it is scoring off the material. And assume that a mechanical engineer has been asked to look at it. It is an embedded system, but a mechanical engineer has been asked to look at it. How do we look at this? So we have split opened and seen what is it, each of the item, and we have also identified what parts it has and how is it working, etc. Then I'm going to look at what we have studied in engineering mechanics, strength of materials. Maybe I'll extend it to dynamics of machine also. I'm treating the arm as a cantilever beam. I'll give a constant force and find out the displacement. I'll just balance the force to the displacement, force balancing. Then keep doing this static analysis. After the static analysis, I'm just looking at the dynamics. I'll just take it as a second order differential equation. I will take all the elasticity present in the system as K, all the mass which is actively participating in dynamics as M. Obviously, I need something else to be considered that we'll see when I'm showing you the experiment as such. And once it comes to this, we know what system responses, what parameter to be looked at, and how do we analyze, and what parameter can be varied in order to get appropriate variations can be very easily found out. Okay, now it is a time for you to do some activity. Please look at this picture. It's a hard disk which is rotating at 7,200 RPM. It's not the SSD, that is not solid state disk. It is a normal hard disk with motor and flaps which is rotating, and the arm which I have shown. There is a hole provided at the one side, normally in the bottom side, and it is written, do not cover this hole. So your task is to find out why this hole is provided and why it should not be covered. Okay, and somebody has written air damping, removing the heat for cooling. Okay, good. Balance of air pressure, very good. Air ventilation, cooling, release of heat. So I'm happy that there are a lot of answers coming in. Again, load distribution, air pressure, good. So here obviously it is, you remember the centrifugal pump? The centrifugal pump, when it is rotating at a high speed, the air around that or the fluid around that, whether it is liquid or gas, it will be thrown out. You will have that whatever mass into omega square r kind of a thing which comes as a centrifugal force, and that creates a high pressure region. So during this, I need something to go out, the air should go out, and when you stop, the air pressure inside will be less because there is no centrifugal force, the air has to come in. So this is called a breathing hole. And breathing hole is very, very common in crankcase, compressor case, and all that. But even when it is an embedded system like this, even here, breathing hole is required. So this is one way of exciting our mechanical students, saying that, look, your understanding is what is required even for high tech to be really working. It is not about just nut and bolt. Even a hard disk to work, a mechanical engineer need to be there. So maybe from here, I'll just straight away go to, well, if this has to be put together, then we need some support. And let us dream about that support. I was mischievous because you are all mechanical. No? So let us dream. Here, in this difficult situation, of course, it is not a right time to dream, but we are dreaming about one thing which is required for us, teaching and learning. But we have three stakeholders, our administration. You go to your HOD or dean or principal or a director, ask, sir, for online classes and to simulate few things, I need this much money and this software and this hardware. Obviously, in this difficult time, he is going to tell, I don't know how many will get admitted, and even my hostels are not being operated, hence even the hostel fee I am not getting, hence I cannot provide you any money. It's a solution which is not costing them much. The teachers, already they have been pushed to online classes, which they were not doing earlier. So we have been learning quite few new things on online classes, and how to take online classes, how to engage our students on online classes. Now, we don't want the professors and faculty who are already tight on their schedule because of the online classes to do more, to do this better teaching in online. And the students are smart, and they have been online all the time. They have been doing good and bad on online, but now they are also interested because the teachers are not nearby. How do they make use of the time? So all the three are looking at the dream, and let us specify the dream. So for students and teachers, we need this learning management system and the lab at my place. And for a learner, at my pace. So if I want to do 3 experiments together, I should be able to do. Or if I want to do the same experiment 3 times, I should be allowed to do. And whatever time I am interested, why only 2 to 5 as the lab class? If I want to do an early morning 4 o'clock one experiment, I should be allowed to do the experiment. Don't ask me what experiment. So the time should not be an issue. The pace at which we are doing should not be an issue. Where I am doing should not be an issue. That is a dream specification. Then we also want lab to be taken home and lab that I can carry with me. Obviously, no lock and key. And this pandemic period, we have already forgotten the holidays. Saturday and Sundays look like Monday and Tuesday for us. And whatever you said and done, whether it is VTU college, affiliated college, or autonomous colleges under VTU, can you provide or can we dream about a lab just for our syllabus? And at the end, we need our students to be getting their dream job. Can I get some help on making sure that we get what is required to get our students the dream job? Our present situation is to change the job or get a new job or shift from IT to core to management, or even a latest area. All that is a requirement. Let us put our requirements together. So these are the requirements which we have put. I want a lab and a learning management system which is at my place, my pace, and my period. And I should be able to repeat the experiment and should be just for my syllabus. Whatever said and done, it is for my syllabus. And it should help my students to get their dream job. Or I should be able to prepare my students to face the interview. All this is my requirement. And solution for that is the virtual lab, which was initiated by Ministry of, old name is Ministry of Human Resources and Development, now it is Ministry of Education, and it is under National Mission on Education through ICT. There are all the 7 IITs and IIIT Hyderabad, Amrita, Dayalbagh, NITK Surathkal, and COIP Pune together built this lab. And each institute has built labs and put everything in one place called vlab.co.in. And every one of you should be able to use it for both online classes as well as a laboratory. And it is free of cost because it is made by taxpayers' money as a project. And how is it functioning? Either it could be a modeling or simulation based program, or in case of strength of materials and the other experiments where materials have to be tested, we test hundreds of material, keep all the data in the server, and when the learner comes to do an experiment and he chooses a brass for testing, take a simulation in the testing, but the data which he gets is the actual data which we got from doing the same material. That is called measurement based. And the king of all virtual labs called remote triggered lab, where we should be able to do an actual lab, actual experiment online. Think about doing an online experiment on an engine and load testing of an engine on online. So it is dreamable. So such experiments are called remote triggered experiment. The concept is simple. You have the lab, and through internet connection using your client device, be it a mobile phone or be it a desktop or a laptop or a tablet, any connected computing device is enough. Wherever it is running a browser, that can do the job. So you don't need generally any specific software. In some Flash for animation, and that too it is getting changed nowadays. Hence, that is also slowly we are updating it. So at NITK Surathkal, where all of you are either already a nodal center, created the virtual lab from NITK, whatever we have created through Center for System Design, which is a transdisciplinary research center, wherein we will not look at which branch it belongs. We look at the problem statement and find out what are the resources required. So the example which I had given you was that hard disk problem. When you say hard disk problem, it looks like it is more an embedded system issue, but it came down to either a mechanical or a civil engineering aspects. So that way, we look at the problem and find solutions. Whatever is the resources required to find the solution or get the solution implemented, we put them together. That's what we do it in Center for System Design. So from this dream, I will straight away go to the demonstration so that you should be able to get So this is a website. In this website, give me a moment. I'm sorry for that break. This is the website. It's from Ministry of Education. And you can see the objectives of the virtual lab is quite well defined. You'll also see a broad area where the virtual labs are created. You can very well go to mechanical engineering or allied subjects. What I will do is I will just click at NITK Surathkal so that I can show you what are the labs which we have developed. So please look at the lab list which we have. Fluid mechanics is something which is required for mechanical engineering. Transportation is civil. Fluid machinery lab. And marine structures lab is actually a structures lab, we can use it. A geology lab we may not be able to, we may not require, but we have mechanics of machine, machine dynamics and vibration, strength of materials, dynamics of machine, and process control, reaction engineering, unit operation, which comes under chemical engineering, but there are quite few experiments which can be used by mechanical engineering. So what I will do now is, I'll take you through your third semester one of the course, Mechanics of Machine. I think it is called as Kinematics of Machine in VTU syllabus. So assume that someone has come to you asking for help in the Viper problem statement which I gave. Okay, so for every experiment you will have details, and I'll take you to one of the experiment. This is called position analysis of crash of a 4-bar mechanism. You'll have a basic theory procedure, then you can do a self-evaluation. After that, you can also simulate. Then there are assignments, quizzes, videos, reference, and feedback. So let us straight away go to the 4-bar mechanism here. Look at this. So this, you can use it the online classes because it is anyway running on a browser. You should be able to show this to the students, and you can stop, change the parameter, and show them what happens when some parameters are changed. This is Grashof alone. So Grashof, and if Grashof is changed, accordingly we can see how mechanisms can be changed, each of this. So you can get at every given theta 2, that is the crank rotation, you can find out the position of all other links. Okay, both open configuration and closed configurations. You can see both how it is functioning. And generally it is difficult for us to demonstrate this in the class because we keep drawing it on the board and look at it. So now I want this green link which is moving. I want to look at it and see how much of energy it has. I want to find out the velocity. Now, position I am able to find out, which is the minimum and maximum. I want to know what energy it has. So I need to find out what is its velocity at every point. So velocity and the mass, if I know the kinetic energy. So kinetic energy gives me the ability to do work or the like. Okay, so that's what I need to look at next. That means I need to find out the velocity analysis. So let us look at the velocity now. Look at this. So velocity at every given theta 2 is possible to be identified. So this diagram we draw it in the class on a board, and one triangle we'll draw, and we'll ask the students to imagine that yes, it is going to change. But when is it going to be zero velocity at one link? When you have the maximum velocity, etc., is difficult to visualize in our normal board activity. So this online gives us one flexibility wherein we can simulate it on online and show them what really is happening. So from here, now I am interested to find out how much force I need, how much torque I need to give. I want to find out what is the mass, then what velocity it has, then I need to look at what acceleration it will have. So displacement, first derivative velocity, then the next derivative acceleration. So when I have acceleration attained by a mass, I get the dynamic force or an inertia force. Either to move, what kind of a torque I need to give, I can identify from that. So I'm now straight away looking at how do I do on a 4-bar mechanism the velocity analysis. Those who are taking this subject will tell me clearly that yes, this could be a boon, because if I had this and shown to my students, they can really get a feel of what is acceleration diagram, what is velocity diagram, how is it changing at every given moment. As the theta changes, how is it changing can be easily understood. And here, suppose you have a previous question paper wherein R and theta and all that is given. So you can adjust that value, and for a given theta value, assume that what will it be? Yeah, kindly mute the mic. Anil Kumar sir, can you mute the mic? Yeah, thank you. So at 120 degree, I want to find out what is going to be the velocity and acceleration at each of the positions. So you can see how it is. Obviously, the acceleration at that point is not very convincingly good. So I'll change it to another position and show you how it is. Look at this. It is at 30 degree. You can see the velocity acceleration diagram. And you can do that for a given question or Anil Kumar sir, kindly close to mute your mic. Anil Kumar. Thank you. So when I look at this velocity and acceleration diagram, it can be used as a problem solving tool. So suppose in a textbook you have some values given, you can type in this value and find out at corresponding points. Or as a teacher, you want to quickly make a question paper, and you can especially put the values here, and that will give you the solution itself, so that you don't need to work out too much. So this is specifically to make sure teachers get maximum amount of time to concentrate on what they are supposed to do, like research and other activity, along with providing good content for teaching and learning. So this is about the purpose which we said was on the Viper, and we can extend it further with the dynamics. I'll just take you to one example for dynamics. Because I'm already on 10:30. So from here, if I just look at dynamics problem statement, I'm just taking it further. Let me just see whether I can show you in a bigger screen. Now, this is called acceleration at CG. Then I will find out what is the reaction force or inertia force which we have. Then you can split this and make the links separate, and then do further analysis. Whether you want experiment on acceleration on CG, or you want to offset analysis, you want force analysis, all that can be done. So this is one activity. Let me go to another example. Suppose someone wants to do an quick return mechanism. Probably you can do using this, and I can also keep looking at what is the angle, what is the velocity diagram, force acceleration diagram, all that. Because normally we will not do this in the class, because acceleration diagram for a quick return with your quick return mechanism is fairly complex. But because it is a simulation and which is done by computing, it becomes very easy. So those who are the students, those who want to get excited a little more, you can push them towards this, and you can even adjust the length. Each of the length can be adjusted dynamically, and the values will keep changing. And I found this is quite easy for me to even set question papers. Okay. From here, I'll just quickly move on to another example of balancing of multiple masses. This is in dynamics it comes. After balancing of dynamic masses, I have a single mass also, balancing of. You can set the parameters, vary it, all that can be done. From there, we'll go straight away to dynamics. Then I'm taking the problem statement from the hard disk. So I want to look at the hard disk problem statement again, and I'll say it is a cantilever beam. I'll straight away go to simulation. Okay. So in the simulation, you can see now, and if I plot the graph, it looks like this. So I'll adjust some parameter. If the arm which is reading the data is moving up and down like this, then obviously you are going to have problem. So what probably we need is, we need to make sure that this, when it is disturbed, it comes only, should not go and score the material. So let us see one parameter I will change, because all of you are mechanical. I can specifically look at the technical term. Damping is what I am changing. So if I can introduce more and more damping, even if I give some energy to disturb the system, it all will get consumed before it comes to stationary. So that's what we are looking at. So if I am able to do this, the meaning is I can control that until the movement which is there. So that really helps in making sure that the disk is not going to be touched by this. So you can keep playing with all this. You can change the material, and different materials, different cross sections can also be looked at. So I can change. These cross sections are taken from standard machine data handbooks. both for mechanical as well as civil engineers can use this. From here, we'll just look at another problem statement. I want to look at this as a 2 degree of freedom system, but I'm looking at M1 as the car mass and M2 as the tire. Okay, so I don't have any control over the undulations on the road. Hence, M2 will be following what the road is and moves up and down. But I want M1 to be stationary. So that's what my intention is. Let us see whether it is possible to do that. Okay, so what I'm trying out is, I need this to be one parameter I'm going to change to show you how differently it behaves. Please look at this. M1 and M2 is moving together. In fact, K2 is not neither getting compressed nor getting expanded. Okay, it moves up and down. Now I'm changing the parameter, the same. Okay. Now see what happens. It is moving up and down, but in the opposite direction. Okay, this is mode 2. Now, if that is a point where I'm able to make sure that, so I should be able to get it in such a way that look at this now. Whatever happens to the tire movement, M2 and K2, my M1 is stationary, and this is what we require really. M2 is stationary, and if we can play with parameter M2, K2 and M1, K1, this is a design activity. We should be able to get such things done. So those who have taken vibration as a subject, at least for me, it was very difficult to convince my students by looking at the equation saying that there is a possibility that it can achieve. And this is also the basic principle on dynamic vibration absorber, which is used in many applications. So from here, let me just check. Beryl, are you there? For Shrestha?
Yes, sir.
What is the time given to me? 10:30 I am supposed to stop, or
10:45, sir.
Okay, I have few more.
10:45. So 10:45 to 11 is the break.
Thank you. So we'll just look at another way of doing the experiment now. I want to do an actual experiment on the same free vibration experiment. Okay. Here the difference is I'm going to connect to an actual experimental setup and see whether I'm able to trigger the experiment. Yes. So this is an actual experimental data which I got. This is the experimental setup. Okay. And this is at NITK. I'll disconnect this. I will show you something which will move so that you can look at this. This is a simple pendulum. Okay. So I'll just trigger first. This is an actual experiment which we are doing. These setups are at NITK Surathkal, and you should be able to access. There is no login and other things. You can straight away connect and use. So you can see that pendulum is oscillating, and now I should be able to get the data. Experiment is still going on. Once the experiment is done, the data will be pushed. It could be due to too much of a network lag. Once the data comes, hopefully I should be able to show you the variation of pendulum length also. Let us wait for a while because it looks it is. Okay, let that experiment be there. I'll try triggering another experiment on the same. Let me see whether I'll be able to do one more experiment. So this experiment, let me see whether I can trigger and see whether I'm getting the data. If network congestion is quite high, the data may not come. I think many are there online on the server. In fact, here we had got the data. So this was the data which we have got from here. So if I can just connect it again, you see this data, I can do a lot of analysis using this. So I can find out, looking at this, I can find out what is the peak here, next peak. From that, I can find out what is the energy consuming element available, that is the damping available, etc. can be analyzed using this. Excitation for a beam is excited by a piece of patch, and in this beam, this is the FFT, that is, you can see what frequency it is getting excited. This is the natural frequency. This is a forced vibration experiment. So this experiment is done. I hope the other experiment also. Now this, I'm not getting the data. Probably there could be an issue. I'll just disconnect this. So with this, I'll just unshare the screen. So what I'm looking at is, when we are asked to go online and take classes, how to make the classes much more effective. Plus the same facility, how do we use it for our laboratory applications? So I have just taken 2 or 3 labs only. My team members will be taking you through the other labs. So those who are not from this domain, don't worry. There are resource persons coming to tell you what can be done in other domains. So I have another 2 minutes. If you have some quick questions, you can ask. Either you can put it in the chat, or you can put it in the chat if you are not able to unmute and talk. Otherwise, you can talk. Another 2 minutes. Then we will break for the a tea break at your convenient place. And
because of this negative sign in the cell.
Hello, sir. Can you hear me? Yes, sir. This question is regarding the remote triggering which you talked about, sir.
okay.
Now, the thing is, this can it be controlled controlled simultaneously by many systems, or
No,
one time?
obviously not possible. At the time, only one system will get the control, but
Okay,
others
sir.
will obviously have viewing right.
Okay.
3 steps now.
Yeah.
Once again.
Right. Thank you.
Somebody has put the mic on. Now, everyone will be able to watch what is happening, but only one will be able to control at a given time. But the time required for doing an experiment is just 3 to 4
Okay,
minutes.
see, the thing is,
Okay,
you
sir.
can't study this on your textbook.
So that way, it is not going to really trouble us, because throughout 24/7 it is available. So any student can come and see when they will also see how many queues are there, which is what time they will get an opportunity to queuing.
I'll read out the
Very, very direct.
okay.
Okay, sir.
I'll read on it. I'll read on.
Sir, I'm having one question. Sir, we are discussing about the moment of inertia.
Okay, now it is 10:45. I think Sreshta, you can break. You can give them instructions what they need to do. I would suggest all of you to come on laptop. Some of you are still on your portable devices, maybe mobile phones. But please come on laptop, so that along with our resource people, they will tell you what to do. And you'll be asked to do 1 or 2 experiments, and probably some of you may be even explaining 1 or 2 experiments. So that way, you can make sure during this period, this one day, you should be able to get things done quickly. Thank you for the patient listening. I'm going to break for another 15 minutes. So thank you.
Thank you, sir.
Thank you, sir. Thank you, Professor Gangadharan, sir. Yeah, so for briefing about with the interesting presentation about what exactly is virtual lab and the flow. So, dear participants, now we have a break for 15 minutes. So, requesting you all to be in the session. So, don't go out of the session. Only you move out, have tea, and come back soon and join by 11 o'clock. So, at sharp 11, we will have one more interesting session from Dr. Prithviraj Umesh, sir. So, thank you all. So, it's break time now. Please join back by 11.